So very good morning, students. Welcome to just welcome to IIT and NEET Foundation classes, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches so far for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7. Our ongoing chapter, circular motion. And today we are entering into the session number 4, or probably the last session, to know about the very important type of motion called circular motion, right? So before going for today's session, let us recall, because today's class is completely grand revision of the chapter with some more addition. So before going for that, let us recall exactly what is the speciality, why the circular motion is the special type of motion. There are so many kinds of motions we have seen in our day-to-day life. We have seen in the chapter also, like linear motion, rectilinear motion, curvilinear motion, vibratory motion, oscillatory motion, random motion. But out of all these things, circular motion is a very important one, very special type, because in this motion, body changes its direction continuously. At every point, there is a change in direction. Even though body is moving at the constant speed, it changes the direction continuously, which results for a circular motion. This type of motion, you can see so many places in our day-to-day life. Yesterday already we discussed it. Starting from washing machine, how the clothes are dried in washing machine, to preparation of pots, movement of the planets around the sun, motion of electrons around the nucleus. All these things comes under a special type of motion, which is called circular motion. So today I will conclude this chapter with knowing more and more about the day-to-day applications of the circular motion. But before that, let us recall that totally here we have what is uniform circular motion. If a body covers, or if a body travels around the circular path, it is called circular motion. In that circular path, it moves the constant speed, is called uniform circular motion. Like Earth revolving around the sun, electrons revolves around the nucleus, or many more. But even though it is the motion is speed is constant, the body passes acceleration. Very interesting, because as it is changing the direction, either velocity increases or change of direction, acceleration will come. Right? That is the speciality of a circular motion or uniform circular motion. So while studying about the circular motion, we learned about the few important terms. How we are the learning motion, which leads for the equations of motion. When you are discussing on motion, we'll discuss about what is distance, what is displacement, what is speed, what is velocity, what is acceleration, what is deceleration. Similarly, here also there. But they are given different terms. For example, we have the radius vector, the first term, radius vector. As in circular motion, there is a radius will come. So the direction of showing the vector, radius is called, because why it is called a vector? Because it moves in a specific direction. The radius following the particular path, that's why it's called radius vector. Okay, that is measured by the length of the, this is called the length. See here, the length of the arc by radius of circle. Radius is this, and length of the arc, we suppose it comes from here to here. So this is called the length of the arc. So this is theta is the radius vector. So see, radius vector is nothing but length of the arc by radius of the circle. Length of, for example, it came from OA to OB. What is the length of the arc? This is the length of the arc. By radius of the circle, we know anyway R. This is the radius along the curve, linear displacement, right? That is the formula for the, so the, whereas angular displacement, the second one, the second definition is angular displacement. Generally, it is nothing but displacement only. But we are, as it is making some angle here, we are calling it angular displacement, denoted by theta. We know displace, what is the formula for displacement? So distance, displacement is nothing but shortest distance. So that is given by radius into, so angular displacement is nothing but a relation is there. The angle made by a body moving from one place to another place. In terms of angle, we are calculating, right? So linear displacement by radius will give normal displacement by radius. Will give the, because everything we have measured with the radius only, will give the angular displacement. So suppose it displaces from here to here. So what is the angle here? This is angle made here. Angle made with the radius with the displaced ball distance, right? That is called the incircular path. That is called angular displacement. We can have the formula in the next page. You can turn to the next page here. So when you see angular displacement unit, angular displacement is nothing but angle. Angle made by radius vector. So it is measured in radian. Radian is the unit. Right? Radian. So angle subtended by the circumference of circle center is given by theta is equal to S by R. S is nothing but linear displacement. R is the radius. So S, what is S here? Total one circle, 2 pi R, circumference of circle. 2 pi R by R. So 2 pi radians. Right? 2 pi radian can be present like this symbol. So, you know, pi is equal to 180. 2 pi is nothing but 360 degrees. Or pi radians is nothing but 360 by 2 is nothing but 180. So, this is the definition for the angular displacement. Displacement by the radius. So, in case when complete circular motion, the displacement is nothing but circumference of circle. That is 2 pi r. 2 pi r by r, r cancel. 2 pi radian is angular displacement. Okay. Now, angular velocity. After displacement, you should know velocity. So, you know, velocity is nothing but displacement by time. So, displacement is nothing but angular displacement by time. Rate of angular displacement. So, angular displacement is measured in radian. Time is measured in second. Radian per second is the unit for the angular velocity. Right? Rate of angular displacement or angular displacement by time. How it changes the angle is measured in radian per second. Right? Then there are some more parameters. Time period, the time taken to complete one circle is called time period. Right? So angular velocity is denoted by omega, remember. So time period is nothing but omega. For example, omega is equal to 2 pi by t, if you think. 2 pi by t. So what is t here? T is nothing but 2 pi by omega. 2 pi is the complete 360 degrees. Omega is the angular velocity. We'll get the time period. Formula for time period. So many formulas you can learn here. Right? Then frequency. We know frequency. Number of vibrations per second or number of revolutions made by a particle per second is called frequency, which is given by, again, 2 pi n. You know, Same thing, if you take omega is equal to 2 pi by t, we can write as 2 pi into 1 by 2, you can write. But what is 1 by 2 is nothing but frequency. That is omega is equal to 2 pi n, or n is equal to omega by 2 pi, which is reciprocal of time period. We know frequency is nothing but 1 by t, or t is equal to 1 by n. Same thing you can apply here. Okay, that is another important formula. Then in uniform circular motion, as speed is constant, equal angles are swept. Equal radius of every second. Thus, angular velocity is constant in uniform circular motion. When the body is moving uniformly, for example, Earth. So in that case, then angular velocity is constant because the body is covering equal time for equal circle. So these all are the formulas important for solving the examples. Now, angular acceleration. After knowing velocity, we should know what is acceleration. We know acceleration is nothing but rate of change of velocity. Velocity by time. So we know what is angular velocity. Angular velocity by angular time here. Angular acceleration is nothing but angular velocity by time. So many ways you can convert as per our requirement. Or angular velocity and linear velocity also given by form relation. V is equal to R omega. You can substitute in place of V, you can substitute R. So many ways you can convert as per our requirement. So acceleration is measured in radian per second square. Right. So angular radius vector, angular displacement, angular velocity, angular acceleration, time period, frequency. These are all the terminology related when a body is in a circular motion. Right. Then, so what is the reason for the body to move circular motion? There are two kinds of forces which already discussed deeply yesterday. There are two kinds of forces which are responsible for body to move in a circular motion. Number one, centripetal force, which is also called center seeking force, which always acts towards the center along the radius, acts radially towards the center, makes the body to move in a circular path. If the force is not there, body will go in tangential path. Because of that force, body is changing the direction and making a perfect circular path. Okay. Then why the body is not coming close to the center? Because of the another important force called centrifugal force, which is called center fleeing force, which acts away from the center along the radius. One is acting towards the center, other is acting away from the center. So both in opposite direction acting on same body, like earth or electron or clothes, whatever it may be. That is the reason body remains in the same orbit and continuously moves around the. So many examples we have seen in the earlier class and the difference. So before going for further conclusion, I'll show you some videos on the applications of centrifugal forces. Where they are applicable already we discussed, but we'll see through video, right?
Moon orbiting a planet, a spinning Ferris wheel, a yo-yo trick called Around the World, the International Space Station. They've all got at least one thing in common.
Find out how they all come full circle next on Real World.
A moon orbits a planet, just like a planet orbits a star, in a curved, nearly circular path. A Ferris wheel curves around a central point as well. And of course, when you go around the world with a yo-yo, it's circling around your hand. And why does all of this happen? Because of a little thing called centripetal force. Basically, centripetal force is a force that makes an object, like planets or other satellites in space, follow a curved path. The word centripetal means center-seeking. What better place to study centripetal force than on the largest artificial satellite in space, the International Space Station? In addition to actually experiencing centripetal force, the freefall environment on board the ISS allows for some really cool demonstrations. So let's send it up to Expedition 22 astronaut Jeff Williams.
So this is
This is a tool.
We'll go for some more video. This is not so effective.
Hello friends, let's see an interesting activity.
Already we have seen this, I think.
Why is the nut
Okay,
coming
once
to the
again,
center?
please.
Because of centripetal force, right? Hi, this is Meena Natsunkar. I just gave a small demo of how I started session in my class. Here, I performed this activity to get your attention. I did the same in my class to get the students' attention. And I found it's a great way to introduce the concept of centripetal force
Once
and
again, revision
centripetal
for
force.
this. Already we have
Here,
seen this
I will
video.
explain 3 easy and interesting hands-on activities that will help students to understand the concepts better. Each activity will just take 10 to 15 minutes. Let's come to our introductory activity. Here, we can ask students to rotate the balloon in different directions so that it will help students to bring their attention to the motion of the nut. After with the nut, we can also try this activity with a coin and can ask the difference between with a nut and a coin to the students. This activity made the students to think why the nut is coming to the center. And this small demonstration helped me to introduce the session's topic. Here, I will again explain 2 simple activities for the centrifugal force. For this activity, we need a thread, a plastic cup, a paper cup also fine, some water and a needle. Make 3 holes on the rim of the cup at equal distances. Pass each thread of equal length through each hole and tie the threads together. Attach a foot of thread at the common points of these threads. Fill half a glass with water. Now hold this assembly like this.
So,
Rotate
how
the
can we
cup
do simple
with
way?
swift action. Now observe what happens. This activity would take approximately 5 minutes. After this
You all can do this in at home also or in school also. Simple activity they are doing. Just a paper cup and making hole like a bucket and hold it and fill it half fill with water and rotate. As long as you are rotating with the same speed, no single drop of water falls from the cup. But when you stop it, automatically it fall down. That is because there is a force called centripetal force. Right?
demonstration, students were curious to know why the water is not falling down even if the glass is upside down. And with the help of this activity, they understood the concept of centrifugal force clearly. In discussion with the students, you can ask these questions like, why is the water not falling down even if the glass is upside down? What is opposing the water not to fall?
That
After
occurs-
explaining the centrifugal force, it made the students to understand it clearly. We can also give a small puzzle to the students to explain the centrifugal force. We will make a spinner that we will rotate on our index finger. For that, we will need a piece of rubber and 2 broomsticks. Here, we can ask the students what is the direction of the force. They may relate this activity with the previous activity and try to answer. Let's see one more activity to explain the centrifugal force. Students can directly perform this activity under the teacher's guidance. Let's make the assembly using 2 transparent plastic glasses, 2 plastic balls, sellotape. We can ask the students how can we separate these balls without touching these balls and without destroying the assembly. After performing the activity, you can ask these questions to the students. What kind of motion separates the balls and why? I think it's now a good time to explain the definitions of centrifugal force and centripetal force. Now we can give another puzzle to the students based on both the forces. The smaller ball has to lift the big ball up. How can we help the smaller ball to lift the bigger ball up without touching any of the balls?
See how beautiful it is.
This is a good example where the students can apply both the concepts of the forces. We can give few chances to the students to solve this puzzle and to know the reason. We can ask the students about the motion of each ball and the forces acting on each ball. For a quick revision, we can ask questions like, explain the concept of centripetal force and centrifugal force. Draw simple diagrams showing the direction of centripetal force and centrifugal force.
Towards
Give
center.
examples of day-to-day life where the centripetal force and centrifugal force are used or experienced. In activity C, identify the types of the forces. Also, identify the type of the motion of the each ball. After a week or so, we can elaborate this concept by asking these questions to the students. How can we separate the butter from the buttermilk?
Turning.
How do pathologists separate the blood cells from the blood? Students can be asked about the exploration of the revolution of the planets and the effect of the centripetal force and the centrifugal force on their revolution, why the earth is bulged at the equator. These questions can be given as a homework and teachers can discuss the answers in the next period. Or students can be asked to perform the following activities in extra class.
Simple way how these activities are there. These 3 activities you can perform at home also.
Or off periods. The links of these activities are given below in the description box.
Right. So it clearly explains the various examples and different way where we can see the centripetal and centrifugal forces which are responsible for body to move in a circular path. Body to move in a circular path means when there is circular motion is there, definitely come across these 2 kind of forces. Out of this, one force is the real force, second force is the pseudo force or imaginary force which only you can experience. We cannot see or it does not have any external agent. Centripetal force is applied by external agent. It may be your finger or it may be gravitational force, right? But centrifugal force, we cannot find it, cannot be given by any external agent. That's why it is called an imaginary force or a pseudo force or a fictitious force. See, there are so many classifications are given. Okay. So there is a machine is also the centrifuge. Suppose if you see in sugar manufacturing also, we'll use the machine called centrifuge. Centrifuge is a device used to separate higher mass particles, higher mass to lower mass particles. So centrifuge is one kind of, just like our washing machine, how it is separating the wet cloth and they are separating the water droplets from the wet cloth. Similarly, in the sugar manufacturing, when you are manufacturing the sugar industry, when sugar is manufactured at one stage will get the sugar crystals with some liquid called molasses, a brown colored liquid. So this molasses is dumped into a machine called centrifuge and it is allowed to rotate with great speed. Then what happened from that? The sugar crystals are separated from the liquid. So how they are separated? Because of the centrifugal force. As the centrifugal force acting on the molasses, it is throw away the lighter particles. Lighter particles are thrown away and heavy particles remain in center. Just like separating the cream from the milk. When you are separating the cream from the milk, so when you are churning with the churner, the lighter particle butter will separate, move out away. Right? Same thing is happened here also. So centrifugal force is the application of centrifuge, which is a machine to separate the higher mass particles from that of lower mass particles. When the particles are mixed, higher mass and lower mass, they can be separated just like a filtration. Centrifugation, we can call it as. Centrifuge is a device used to separate high mass particles from lower mass particles. That is also one of the important application in the sugar industry, where sugar crystals are separated from the molasses in the final stage. After separation, they are dried and they are packed. Okay. So when you see the magnitude is for strength. So centripetal force and centrifugal force have same magnitude. That is given by F is equal to mv square by r or mr omega square, because we know v is equal to r omega. So either centripetal or centrifugal have same magnitude, but direction is opposite. They act in the opposite direction. Same magnitude, opposite direction. So definitely the body is in the equilibrium state. So magnitude of centrifugal force F is equal to mv square by r or mr omega square, where v is the velocity of the body, r is the radius of circle, omega is the angular velocity, m is the mass of the body. Right? So direction of centrifugal force, it is directed away from the center. So centrifugal force is always away from center. Centripetal is towards center. That's why it is called center seeking force, center fleeing force. So examples. During the motion of the planets around the sun, the planets experiences centrifugal force in the form of gravitational force. Then second one, in the revolving electrons around the nucleus, right? Also same. When a moving car takes sudden left turn, a man sitting in the back seat falls away on the right side because of the centrifugal force. Okay, so you see some solid examples are given before concluding the chapter. A particle moving along a circular path, okay, describing an angle of 45 degrees. So theta is equal to 45 degrees and in time is equal to 0.2 seconds is given. Calculate the angular velocity. What is angular velocity? Omega. Angular velocity of the particle in degree per second, not radian per second, degree per second. And second one is radians. Both you have to do. So first, angular velocity omega is equal to pi by t, angular displacement by time. That is 45 degrees by 0.2. That is 22.5 degrees per second. So 45 by 0.2, no? 225, sorry, 225. 45 by 0.2. So point remove and put 0 here. 450 by 2, 225. 225 degree per second. Second, we know 360 degrees is called 2 pi radian. How many degrees we got? 225 degrees. So 225 degrees is equal to how many radians? Cross multiplication you can do. Right? Cross multiplication. We can get 3.928 radian. Right? See, 360 degrees is equal to 2 pi radians, right? But how many degrees we got? 225. So 225 is equal to how many? So cross multiplication. We can do. Pi 22 by 7 you can take. So 360, 225 into 2 into pi 22 by 7 by 360. So same thing what he has done here. 3.928 radians. Okay. The simple formula application, direct application of formula. Next, second one you can see. A centripetal force, 50 Newton. Force is given. Acts on a body of mass 2 kg. Moving in a circular path of radius 4 meters. So, force is given 40 Newton. And mass is given 2 kg. Right? And radius is given 4 meters. So, calculate the uniform speed of the body along the path. You have to calculate the speed. So, centripetal force is given R everything. So, formula is there F is equal to mv square by R. Right? So, you get the velocity from here. F is there, m is there, R is there. What is not there? V is not there. So, V is equal to Fr by m. Formula is given here. So, we'll get the finally V value as the speed is 10 meter per second. Got it? So, by the way, direct application of formula only. F is equal to mv square by R. He has to find speed, that is V. So, remaining all are there. V square is there, so V is equal to R by M. F is there, 50. So, or if you substitute the values, you can get the value as under root of 100, that is 10. 10 meter per second is the constant speed of the body in circular motion. So these are the two examples. So many are there in the worksheets. You practice those worksheets in coming days so that you can appear for the examination. That is weekend test number 7. Okay. So these are the few more examples before conclusion of the class. Few more examples for the centripetal and centrifugal forces. Right. See, centripetal force examples are given. Centripetal force is the real force which always acts radially towards the center, which has an external agent. So, a force that keeps an object to move in circular path at constant speed is called centripetal force. The force of a string on a ball being spun. The string when you suspend the ball with string, the string makes the ball to spin. The friction force between the axial and surface of the rotating automobiles. In automobiles, there are so many machines there which rotates around the axial. The force of back and back seat pushing an astronaut in a centrifuge. When astronaut goes on sea, there is also force acts with the pushing the astronaut. Then centrifugal force. A force that causes object to move away from the center of the circular path. Mud flying off from the tires. When you are traveling on mud road during the rainy season, the mud will go back in a tangential direction towards the back person. It spills towards back. That is because of the force acting, centrifugal force. Children being pushed out of the round out. When you are rounding a circular, you are pushed outside by the force called centrifugal. The force dries the clothes. Dries, not dies. Dries. I already told. Drying of clothes also one of the example of the centrifugal force. So these all are the examples for where the forces acts on that and makes the body to move in a circular path. So this is a small and very interesting and very important topic, circular motion. Right? So with this, we are concluding this chapter now. For the time being, the chapter is concluded. We have only one more chapter left in the material last. So before that, once go through the worksheets, if I get the time after the next classes, I will go through the worksheets also of this chapter. And meantime, you can prepare well entire chapter circular motion. It's a simple topic, but having the powerful concepts, the applications in our day-to-day life. So there are many more examples you can correct and you can exhibit these effects in your science coming science fair also, because this centrifugal force will explain it nicely, either by planetary motion or by electrons or by many more activities. You can show the exhibits showing the centripetal and centrifugal forces, right? So that's all for today. Thank you very much, students. Have a wonderful day. Have a wonderful weekend. Thank you.